Hi everybody, this is Mrs. Danielson, and today we're going to talk about radians and how you switch between degrees and radians. In calculus and in higher math classes, you're going to use radians a lot, so you may not love it, but we're going to use it. So today we're going to talk about what radians are and how to convert back and forth between the two. For the next 3 chapters or so of pre-calculus, this is something we'll be using quite a bit, so we're going to go ahead and just dive in today and get started on it. So the first thing we need to do is we need to switch over here to my iPad so we can take a look at a few problems and get going. One of the first things we're going to do with this is we're going to talk about positive and negative angles. We've always had positive and negative angles when we were working with degrees, and we're still going to have them. So let's just touch that really quick. For positive and negative angles in degrees, we always started at the positive x-axis, and a positive angle was one that started at the positive x-axis and then moved in a counterclockwise position, like this one here on the left. This was a positive angle. We started at the positive x-axis, and then we ended over here on the terminal side. Let's see. So it looks like this one on the left, terminal side. So again, it started at the positive x-axis and then it moved in a counterclockwise position, and that's an example of a positive angle. It was with degrees. It'll still be a positive angle with radians. It's the same thing. The one on the left, right, starts at the positive x-axis. But in this case, we go in a clockwise position to our terminal side. And that's an example of a negative angle. And it's still going to be a negative angle now that we're working with radians. So whether it's degrees or radians, positive angles, negative angles, same thing they've always been. Okay, so we just need to touch on that because we will be doing quite a bit with negative angles when we're working with radians and trigonometry. Okay, so the next thing we're going to talk about is what a radian is. I'm going to go ahead and just snag this little circle first before I start writing on that. And I'm going to duplicate it and copy it down here a couple of times before I start doodling on it. Let me grab that one more time too. All right. Okay, so the first thing is a degree. We've been working with for a long time. We know it's 1/360th of a circle. A radian is a little bit different. 1 radian is if we're in a unit circle, and a unit circle means that I have a circle with a radius of 1, and 1 radian would be about this big, and I'll explain why in just a minute. Okay, the first thing I want to do is I want to draw a unit circle with a circumference all the way around of 2 pi, right? 2 pi, that goes all the way around my unit circle. That's the circumference of a unit circle that has a radius of 1. Okay, and I think we all agree that's true. 2 pi is the circumference of a circle with a radius of 1. So for this one, the angle of this circle in radians is 2 pi. Now, if I just went around halfway, and again, we're talking about a unit circle, if I went halfway around, that angle would be half of it, right? It would be half of the circumference. So it would be pi. Okay, so halfway around is pi. What if I just went a 4th way instead? And again, we're talking about a unit circle here. Then this angle would be half of that pi, and it would be pi over 2. Okay, so what have we learned from those 3 circles? Well, we've learned that 360 degrees all the way around that circle was 2 pi. We learned that halfway around that circle, which is 180 degrees, was 1 pi. And we learned that 1/4 of the way, our 90-degree angle, was pi over 2. And that is our first step in learning about what a radian is. Okay, 2 pi radians is 360 degrees, and 1 pi radian is 180. and pi over 2 in radians is 90 degrees. Okay, now let's say we didn't really want to use radians with pi in it. Then how could I do radians without the pi in it? Well, right here, if we did this half a pi again, just like the one above it, that's pi at 180 degrees. Pi is 3.14, right? Is a number, approximately, again, not exactly, but approximately 3.14. Okay, so that would mean that right here, right, that's about 1. Right here would be about 2. Right here is about 3, and then that's about 3.14. So that means right here is about 1 radian. And then right here is about 2 radians. And right here about 3 radians. Okay, so that's where we came up with that little circle at the top. So I could say this angle is 1 radian. Or I could say that one right there, that's 2 radians. Okay, so that's a real quick little lesson there on what a radian is and how it's different than degrees. But the thing we're mostly going to be doing in this little section here, and what you'll be doing on your assignment that goes with this section, is you're going to be converting between degrees and radians. So how do we do that? How do we convert between the two? Well, I know that 1 radian is equal to 180 degrees divided by pi. Remember, 180 degrees is equal to pi. We see that on that little circle up above right here. So I can multiply my radians by 180 over pi because that's 1. Okay, and I also know that 1 degree is equal to pi over 180. Okay, knowing those two things is going to help me do my conversions. Okay, so to convert degrees to radians, you're going to multiply by pi over 180 degrees. Okay, and you'll get your radians. And to convert radians to degrees, you're going to multiply by the opposite, 180 degrees, over pi. Okay, let's do an example. We'll do one together, and then I'm going to have you do one by yourself. Let's say we want to express 60 degrees in radians. Okay, so this is an example of needing to convert degrees to radians, that first one. Okay, so you do 60 degrees and you multiply that by pi over 180 degrees. Okay, that would give me 60 times pi over 180, and then you simplify that. Okay, I can simplify that because 60 goes into 180 3 times. So that would give me pi over 3, or pi over 3 radians, and that's my answer. Okay, let's do another one that's switching from degrees to radians. Okay, let's say we want to express 20 degrees in radians. Okay, I want you guys to pause the video and do that one on your own for a minute. Once you have the answer, then turn the video back on again and see if you get the same thing we do. Okay, so pause the video, make sure you reduce. Okay, all right, hopefully everybody got an answer. Now let's do it together and see if we get the same thing. Okay, so you're gonna do 20 degrees times pi over 180 degrees. So that's 20 degrees times pi over 180. You always have to reduce when you're switching to radians. Reduce as much as you can. Okay, so that's going to give you, how many times does 20 go into 180? Goes in 9 times. So pi over 9 radians is your answer. Okay. Now let's do a couple converting radians to degrees. Let's do the opposite. Okay, so let's express, let's say pi over C6 in degrees. Okay, so now we're going to do that second one, converting radians to degrees. So we're going to take our pi over 6 and we're going to multiply it by 180 degrees over pi. Notice what happens there when you are multiplying these. What happens to the pi? The pi's go away. Isn't that nice? Leaving us with 180 degrees over 6. And then you just reduce. Reduce as much as you can. In this case, it reduces nicely to 30 degrees. So pi over 6 in radians is 30 degrees. Okay, let's do another one. You're going to pause the video and see if you get the same answer we get together. Okay, let's do pi over 9. Oh, look, we can't do that one. We already did that one. So we're going to do a different one. Let's do one that's negative, right? Let's do negative. Let's do a little bit harder one. Let's do negative 10 pi over 9 in degrees. Now your question has a degree that's negative, an angle that's negative. Your answer will too. It'll still be negative. It doesn't change. It's a negative. It's going to be a negative. Okay. So go ahead and pause and solve it. Okay. Hopefully you're playing the video again. You found your answer. Let's see if we all get the same answer. Okay, so you're going to do negative 10 pi over 9. Multiply it by 180 degrees over pi. Okay, those pi's cancel out. Okay, and that gives you negative 10 times 180 degrees over 9. And then you just simplify as much as you can possibly simplify. And your answer is going to be negative 200 degrees. And hopefully everybody got that. Okay, and that's it for radians, just your beginning introduction to radians and practicing converting between degrees and radians. And I hope everybody had a good experience with that first introduction to radians, and everyone have a great day and have a good time practicing that skill.